Hello, Java students. Today in this virtual day, we are going to investigate abstract classes. If you guys go to your Google Classroom, I have posted, the most recent post would have been finalized in Templetop 10. That's not going to happen today. Down below on December 20th is where I posted all the notes for Chapter 10. And I believe it's going to be part 4, classes continued with inheritance. Yeah, it looks like this is 10.6 in our physical book. The online book is actually 11.7. So this is what we're going to look at in today. I will go ahead and fill in these notes if you guys would fill them in as well. And then you guys are going to create the abstract class from the online book or your physical book. So that's pretty much what we're going to do today. So I'm just going to try to keep the video quick and hopefully less than 8 minutes. And then you guys can go ahead and put this abstract class together in Eclipse. So here are the fill-in blanks here for our notes. An abstract class cannot be instantiated. An abstract class is similar to an interface. The only thing is it is allowed to have variables. The interface did not have variables. The interface just listed all the methods, and that was it. An abstract class not only has variables, but it also has defined functions in it. It implements, or will show you the implementations of some of the methods in the abstract class. Okay, in the abstract class, you can have abstract methods. Those are methods that have no code. There's no defined implementation in the abstract class. All that is going to be done in the subclasses. Just like the draw for each of the circle, the rectangle, and the wheel and your triangle classes, that has to be customized. So we have to declare that method is going to be a part of this hierarchy. So we define it as abstract if it's going to be customized below in the subclasses. We use the word abstract to define abstract classes. And again, just stating here that it must be defined in the subclasses. Now, some of the classes we do not have to repeat over and over again. Like the circle class has get exposition. The rectangle class has get exposition. If we define a abstract class, we don't, and every subclass has it, then we can define it and we can tag final so that no one below can alter it or change it. None of the subclasses can change it. It's final. It's a constant. So you can think of it in that term. Okay, let's go ahead and talk about the abstract shape in the textbook. Here is the online book. Yeah, and I'm going to start right here. It's on page 406. Okay. We are going to develop this abstract shape class, which is an abstract class. An abstract class cannot be instantiated, just like that. And if we are able to instantiate a class, that is called a concrete class. I'm not sure if that is a vocab word in this chapter or not, but so here's what we're going to do. Here is the overall view of this. We are creating this right here. We are going to let it implement the shape. You don't have to let it implement the shape, that interface, but you can if you want to. And I think they just leave that in there to show you that it is possible that you can do that. But the focus is just going to be on this. Circle, rectangle, and wheel. We are trying to get rid of redundant code, try to make things more efficient. And there are some variables in here that we could ultimately just put right into this class, and then it can be shared or inherited through its subclasses. So here is the abstract shape class. It's going to implement shape. You don't have to, but it can. And notice that the word abstract is in front of it. That tells the compiler that you cannot create or instantiated, it is a data type. And here's our common variables throughout the whole hierarchy system. X position, Y position is going to be peppered throughout the whole thing. You protect it, just like we did before. Here is our constructor for abstract shape. You can pass in the X, Y, X loc, Y loc, and pass them into your positions. And here's where I was talking about abstract method. Here's an abstract method. Notice that there is no code for this. There's no implementation of area. And that is because it could be a circle, it could be a rectangle, it could be a triangle. It has to be defined. This method has to be customized underneath into its subclasses. That's why we label it as abstract. We label it so that they all have the same area. It's polymorphism. We're trying to make all the methods the same name. I don't want area of circle, area of rectangle. We just use the word area, and its implementation is defined by a subclass. The same thing with draw. Oh, here's the X position, Y position, and I think move is down there. Yes, it is. And notice it has final. There's no abstract here. We're defining it. We're defining it in this class right here, and we're making it final, so no subclasses can alter it or change it. Stretch by. Stretch by is another abstract class. Notice that there's no implementation, meaning there's no code for this method. It's saying that stretch by is defined by its subclasses down below, but it is part of this hierarchy system. And toString, this is a special one. There's no word abstract in front of it, and there's no final. It is listing a portion of what we are used to seeing in this toString in this hierarchy system. So it's actually giving our position in the area. Okay, so here's the circle. There's some changes that we have to make to the circle, not the header. Oh yeah, it does. The header is going to extend the abstract shape. Yeah, so in the header, change it to extends abstract shape. So therefore, circle has a superclass called abstract shape, which means the radius. I think that should be protected. That's already been done. We are going to change our constructors. We are going to use the super. Let the radius equal 1. You could let it equal 0, but we're initializing it to 1 in the book. Down here is super. We're going to pass in the X, Y loc, X position, Y position, and then assign our radius to whatever the user or the client is requesting the radius to be. Here is the area. Nothing is changing here. It's being defined in that class. There is the draw, no issues there, same thing. There's the stretch by. So far, the only things that we need the redundant code, all the final codes that was listed in the abstract class itself, the get X position, get Y position, and the move, and I think those 3. We can now eliminate them in here. It's redundant. We don't need it. Put it up in its super class, and we don't need that code any longer. Here's that toString. Okay, so this is interesting. The toString, we're going to design the toString. Yes, there's a toString in a superclass, but it's a portion of it. We're gonna start out with the whole circle and the radius. I think we have that already, but underneath this, we had that position and area. We'll just call up the superclass because now it's defined in the superclass. So again, we're trying to eliminate redundant code. Okay, now go to your wheel class. I'll spend a little bit of time with this and then I'll conclude the video. The wheel class, nothing's changed in the header. Nothing's changed with its instance variable spokes. The constructors, I don't think that's already in there. The wheel superclass is circle. It is not the abstract class. Remember, the superclass is only one class above it. So this is going to the circle. And then once it gets to the circle, it goes to its superclass, which was the abstract shape. But the wheel has to go to its parent, its superclass first. Okay, same thing with the constructor with parameters in it. Draw, yeah, I don't think I have to change anything in draw. The area, I don't need to put area in here. I don't think nothing has changed in here at all. Set spokes, I think we put that in yesterday or the day before. And the only thing that is goofy is a 2-string again. So we have a 2-string. We are going to put the customized wheel. We cannot put super dot 2-string because I don't want it to say circle. And I also have spokes, so I have to actually, this is all going to be custom. And you're thinking, well, the abstract class has this, so I can't put super dot 2-string. Again, it only has one super class, so it doesn't align. And this is that one case where we're going to have to just rescript all this in its in this 2-string. Okay, I hope this makes sense. Go ahead and fill it out. You will have to make some changes to your rectangle and in your triangles, but at least get the circle and the wheel class to work. Rectangle, I think you could probably follow the book here and figure out what it's doing. The triangles, if you guys have the code, and you should be able to make those changes. But we can talk more about it in class in person. If you have questions, feel free to shoot me an email, and we can Zoom together if you would like. But go ahead and attempt this, and again, just reach out if you have some questions.